All right, so the last couple lessons we were looking at how to name chemical compounds. If there are any questions or any issues with that topic, please let me know. We are going to go ahead and move on to counting atoms. So if I have a compound like dihydrogen monoxide, water, you will have what's known as a subscript. This subscript tells you how many of a particular atom you have. So this tells me I have 2 hydrogens. I don't have a subscript next to water or next to the oxygen here in water, and that's because if it's already there, you kind of already understand that there's one present, so there's just one there. If I have a big number in front, this big number is known as a coefficient. And this tells me how many water molecules I have. It tells me I have 2 entire water molecules. And so let me go ahead. I will draw out 2 water molecules. So your colored circles are your hydrogens. Your non-colored circles are your oxygens. And so here I have 2 water molecules. This coefficient can be thought of as a distributive property and can be multiplied out. So if I have 2 water molecules and 2 hydrogens, I know 2 times 2 is 4, telling me that I will have a total of 4 hydrogen atoms. And if I look at this, I have 1, 2, 3, 4, which that kind of matches up. So I can definitely say I have 4 hydrogen atoms. If I look at oxygen here, remember oxygen is a 1, so 2 times 1 means 2. And I can look here at my drawing and I can see 1, 2 oxygens. And so this is a quick example of counting atoms. Now, this is just the first example. There's going to be a few more, so don't worry if you don't understand it just yet. But we're going to go ahead and we're going to look at MgCl2, magnesium chloride. Remember, this is an ionic compound. The metal will keep its name. Chlorine will drop its ending and become -ide. So magnesium chloride. Mg, there's no subscript, so that tells me that there is only 1 magnesium present. I have a subscript next to chlorine, and again, that is only going to chlorine here. So that means I will have 2 chlorines. Now, if I had a coefficient, and let's just say I have 3, I still need to count out how many magnesiums I have and how many chlorines I have. Your coefficient is more like your distributive property, meaning that it's going to be multiplied out. So I know that there's already 1 here, so 3 times 1 is 3. 3 times 2 is 6. So again, if I'm wanting to kind of draw these out, let's have magnesium be purple and chlorine can be orange. I know that magnesium chloride by itself will have 1 magnesium and 2 chlorines. And of course, our coefficient of 3 tells me that there's 3 of these molecules present. So I'm going to draw out a total of 3 magnesium chlorides. And this is just a visual representation, so I can visually see that I have 1, 2, 3 magnesiums and 2, 4, 6 chlorines. So let's go ahead and pick up the difficulty level just a little bit. I have, let's see, make this our third example. And we're going to look at 4HNO3. Again, my coefficient can be distributive, so it goes to every element here. I know that I have hydrogen, nitrogen, and oxygen. Just being present, I know that I have 1 hydrogen, so 4 times 1 is 4. Just being present, I know that there is 1 nitrogen, so 1 times 4 is again 4. And last but not least, I have 3 oxygens, so 3 times 4 is 12. So this is an example of counting our individual atoms. Now, I'm not going to waste time with drawing out 4 different molecules of this, but I can tell you right here, it will look very similar to when we were drawing out our molecules here for magnesium chloride. So let's go ahead. Let's do something with a little bit of the same difficulty level. Let's look at 2CH3OH. Again, my coefficient can be considered distributive, so it can be multiplied out. I look at carbon, hydrogen, and oxygen. Those are the 3 elements I have in this compound. 2 times 1 is 2. I'm going to skip hydrogen. We're going to come back to that one. There's only 1 oxygen. 2 times 1 is 2. Now, without my coefficient, I have a total of 3 hydrogens here and 1 hydrogen here. What you're going to do is you're going to add them together. So 2 times 3 is 6, and 2 times 1 is 2. So let me go ahead, 6 and 2. What you're going to do is add them together. So 6 plus 2 is 8. And that means we'll have a total of 8 atoms. Now, when we start getting polyatomics involved, polyatomics, again, were NH4 or PO3. These were polyatomics. They would keep their name. So this would be ammonium or phosphate. When you start seeing polyatomics involved, you're going to start seeing parentheses. And so we have an example of 2 SR3 PO4 2. I would look at my different elements. SR is an element. Remember how we would tell a difference? A capital letter is always first, followed by the lowercase. Lowercase letters will always come second. And again, if we see another uppercase or another capital letter, you know it's a different element. So SR is a single element, phosphorus is an element, and oxygen is an element. We know that the coefficient will be distributive. It will go out to each different element. But within our parentheses here, we have a little 2. And so this little 2 right here means that within the parentheses, we will go ahead and we will also multiply it a third time. So let's go ahead and let's pretend we don't have a coefficient first. Let's pretend we don't have this. We would have 3 SRs. Within our parentheses, I have 1 phosphorus, but this is distributive, so 2 times 1 is 2. I have 4 oxygen, but again, this little 2 is distributive, so 2 times 4, 2 times 4 is 8. Now let's go back and look at our coefficient. This coefficient would be, again, multiplied, so 2 times 3, 2 times 2, and 2 times 8. So I would see 6 SR, 4 phosphorus, so 4 Ps, and then 16 oxygens, 16 Os. And so this is probably one of the most difficult examples that you will see, is whenever you have to distribute within the parentheses and then distribute your coefficients. So today's assignment is pretty straightforward. I am just assigning this worksheet. So you only have 12 problems that you need to complete for today. And so you have right here, we've done an example with water. We've done an example with magnesium chloride. We've even done an example with HNO3. So today, what you really need to do after this video is work on this worksheet. If you have any questions, please let me know, because our next class on Tuesday, I'm going to be giving you a worksheet that looks more like this, where we're going to have our more difficult examples. So please let me know if you have any issues. Today will be the last day that I'll be looking at any late work, because I will be finishing up grading everything here by the end of the week. So any questions, let me know, and I hope you have a wonderful weekend.